Region Chairman, IIF, to introduce our first speaker for the day, Mr.Y Gopal Rao, Director, Operations, Kusalava International Limited, to our audience.
Thank you. Dear fellow Foundrymen, ladies and gentlemen, a pleasant morning to one and all. With great pride and honor, I have to introduce our speaker of the first session, Mr. Y Gopal Rao, who is going to talk us about challenges in liner production. With great enthusiasm for educational strengthening, he completed B.Tech in Mechanical Engineering and started his career. 28 years of experience made him rich in knowledge, and he is well known for his positive and motivational attitude towards addressing the issues. The simple man is currently Director Operations in Kusalava International Limited, Vijayawada. Ambition to develop multi-talent in his profession fetched him Six Sigma Black Belt and also certified IATF auditor. In order to turn the visions into reality, he visited Japan, Korea to benchmark the best liner manufacturing practices and implemented the same in Kusalava International. Services rendered by him to their business partners attracted more OEM customers to his company. Implementing and practicing TPM and TQM enriched the business values of Kusalava International even today. Leaders become great not because of their power, but because of their ability to empower others. The poet said one day. Thus, I would like to introduce Mr. Y Gopal Rao, one of the leaders of Kusalava International, to this august audience. Dear fellow Foundrymen, ladies and gentlemen, please give him a round of applause, and I welcome Mr. Y Gopal Rao, and the floor is yours, sir. Thank you.
Thank you very much for the Indian Institute of Foundrymen for giving me the opportunity to present here. I am going to explain you today about the cylinder liner manufacturing and also some of the challenges what we are facing and how we are handling this. Kusalava Group, it is a private owned company based at Vijayawada in Andhra Pradesh. And as a group, we have manufacturing, trading and service. So as a part of manufacturing, we are doing automotive cylinder liners. And also recently we launched the electrical two-wheeler manufacturing. We started a plant in Hyderabad, and it is called as Quantum Energy. Our brand is Quantum Energy. And we are the dealers for the Hyundai cars in Andhra, for almost like 5 districts in Andhra Pradesh. And also we have our own finance company where we do the financing. Sir, our group turnover last year, it is around 600 crores. We have 4 manufacturing plants in India. So all 4 manufacturing plants, we make cylinder liners. So we have 2 plants in Vijayawada and 1 plant in Visakhapatnam and 1 plant in Pantnagar, that is Uttarakhand. So all these 3 plants, out of 4 plants, 3 plants we are having foundry and machining, and 1 plant in Visakhapatnam we have only machining. So we do casting and rough machining here in Vijayawada, and we send the rough machine parts there. So coming to the organization structure, Mr. Chukkapalli Ramakrishna Prasad, so he is our managing director, and Mr. Chakravarti is our technical director taking care of the business. And if you see, we are the senior management team. We have the US office, so we have one president there who takes care of our US business, and I takes care of all plants operations, and I have the team with various plants who are supporting me for the operations. And some of the milestones and quality excellence, so from the beginning we are very much oriented about quality. So in 1994 itself we got the ISO certificate for our this thing. Now our all plants are IATF certified, and we are ISO 14001 certified company. And we have the Lloyd's registration certification, and also we have the in-house R&D for the process development. and it has been certified by Government of India. So these are all our esteemed customers. So we supply to all the Indian OEMs, especially commercial vehicles, tractors, and LCVs. And we supply to, sorry is there, so we supply to Simpson, around 30 to 35,000 liners every month we supply. And all the customers, we have more than 75%, or we have the single source status in many of the customers. We have a lot of overseas customers, and out of our turnover, we are expecting some 400 crores turnover this year for liners. Out of that, 40% will be coming from export, and around 40% will come from the domestic OEMs, and we have our own brand in the aftermarket. So we do around 20 crores, 20% of our sales comes from the aftermarket. Now I'm just going to explain how we make these cylinder liners. So we have different materials we use. Basically, it is a foundry grey cast iron. It's class 30, class 40, class 50. These are the grey cast irons what we do. And also you can see many of the microstructure, which is very important for the foundry. So we have the different kind of microstructures based on the customer requirements. Actually, I just want to tell you, we are not going to design the liner. So we get the drawings from the customer. So as per the drawing, we will be designing our process and to get the required properties. So, and we do some liners with binet iron. It is a different grade of iron where we maintain a lot of alloyings like moly, nickel, where it will give a lot of hardness, high hardness, and also good wearing strength. And we do ductile iron, SG iron liners, what we call it as XG iron liners. So these liners we supply to one of the US customer as for the racing car application. Actually, it is called drag racing. So for each race, they have to change the sleeve, that is a liner. So we developed the liner in such a way that same liner has been useful for the 4 racings. So the customer was very much delighted, and we became the single source for him, and we supply only 5,000 numbers, but is very high value items. So that is the Darton sleeves in US. And we do some steel liners. Volume wise it is less, but we do a lot of variety of liners. So as a part of that steel liners we do for some of our export customers. And now I am going to explain the foundry process, how we will do the casting process. Basically, it is a centrifugal casting. So if you see the basic flow chart of a casting process, so we have the raw material bins where we maintain different compositions for different customers. So we transfer the raw materials to the through charger or through magnet to the furnaces, and we do the induction melting. So we have the inductothermal induction furnaces. Then we do the spectro check. Then we have the corrosive machines where we use for the water cooling as well as air cooling. And then we do some refractory coating into the mold to avoid the metal to metal contact. And then we do the pouring. Then due to the centrifugal force, the casting will be formed, and we do the casting extraction. And then we do some shot blasting, casting inspection, then parting. So this is the typical foundry process flow, what we follow at our factory. So these are some of the critical process and foundry. Raw material bins, even though it is a storage of the raw material, it is very important for us. There should not be any mix up with the different material, because one customer don't want any nickel in his composition. So that's why we will maintain different bins. And also, as I told you, we use all the induction furnaces, and we have an online display at the furnace, which will be connected to the spectro lab. So once the inspector will do the check in the spectro lab, directly the readings will be displayed at the furnace, so that the melter can release the material, or the hot metal, to the pouring. So we have the online display system. And this is our casting process. You can see casting process. As I told you, we have the automated corrosive machines where we do the pouring. And it is very important for the microstructure, hardness, all these defects It is very casting process is very important for us. And then after casting, we do shot blasting and then parting. It is a part of the casting. And these are the testing equipment what we have in our plant. All the testing equipment which is required for a casting, we have in-house. We have two spectral labs, and we have all the image analyzer, hardness testing machines for the component checkings. And these are the critical characteristics, what we call it as customer. Sometimes he will give the critical characteristic for any liner. If customer doesn't specify, but we have our own critical characteristics which really affects the fit and function of the liner. So based on our experience and all, so we identified always chemical composition, hardness and the microstructure is very, very important for a cylinder liner manufacturer. So these are some of the process control. Sir is talking about some of the process control. Foundry, always it is we cannot check 100%, we cannot do any destructive testing. So we have to maintain the process control. So if you see, we have a lot of process controls in our foundry. I can say one is inoculation addition. Normally people will do inoculation addition with manual, but we have online screw feeder. We load the inoculation in the screw feeder. So during the carousel machine operation, as a part of PLC program, once it comes to that particular station, inoculation will be automatically added through the screw feeder. And also we have online die temperature, online metal temperature, online RPM meter. All these things we have online. So we are very much confident about our process control. You can see any pouring also, we do automatic pouring. No operator intervention in the pouring, because pouring time also is very important to maintain our casting defects. So these are some of the improvements what we do. And we have automatic manual, automatic casting extraction, and also automatic die cleaning, because manual cleaning is always a problem. If the operator is not cleaning the die, we will get the casting defect. So we have the automatic cleaning also in our foundry. So this is a brief about our foundry process I want to explain. And then coming to the machine shop, we do a lot of machining. Along with the casting, we do a lot of machining. So this is the typical machining process flow. After getting the casting from foundry, we do some rough machining, rough boring and rough turning, and then some CNC turning, then we do grinding, then we do honing, and then we end of the line, we have the inspection, and then after inspection, we do laser marking, and based on the customer packaging sign off, we do the packing of the parts with returnable pallets or with regular pallets. And these are some of the machines. We have a lot of CNC machine, Mazak and Ace and Jyoti CNC machines, and we have Nagel plateau honing machines. So for cylinder liner, honing is a very critical operation to maintain the oil retention time and also the oil consumption. The performance of the engine is based on the honing pattern. So we have a lot of honing machines, Nagel plateau honing machines, and all the testing equipment also we have in-house. All the CMM, roundness testers, roughness tester, whatever it is required for our liner manufacturing, we have in-house. And these are some of our lines, production lines with different this thing. And these are like foundry. In foundry, we have chemical composition and all. Similarly, we have very critical characteristics in machining also, like cylinder liner flange width or the outer diameter. All these things are important parameters. And we implement the SPC, statistical process control, to maintain the CPK of the process requirement, 1.67. So these are some of the parameters. And this is about the grinding. The grinding also is a very important operation for a cylinder liner. So here also we do the X-bar chart, and also for roughness we make some run charts to see the process consistency. And this is what I am talking about, Nagel plateau honing. So for cylinder liners, plateau honing is very, very important. So we do plateau honing in 2 stages. We call it as base honing and plateau honing. So here also we have critical process parameters captured during the part of the initial product development, and those parameters will be maintained across the machining lines. And also we have controls, as I told you, X bar R chart and run chart for different parameters. And these are the inspection and testing what we do for cylinder liners. So we have air gauge, V-block, and also the measurement, Meher roughness tester, where we do some this thing. So these are some of the testing and inspection what we do in machining. And quickly I am going through the surface treatment process. We do some surface treatment for some of our customers. So we do phosphating. We call it as a manganese iron phosphating. So we do phosphating to retain the, I can say, oil retention as well as to avoid the corrosion. We do the phosphating operation. This is the 10 tanks phosphating. You can see there are 10 tanks which we are having to do the phosphating with a proper PLC control. And we do through hardening, and we do this tempering and annealing, stress relieving, and induction hardening. For some of the export liners, we do induction hardening where it will give the case depth. Liner ID will be done hardened, and we maintain case depth, and also hardness will be very high during the engine running. Small quantity of gas nitriding liners also. For our Cummins customer, overseas Cummins customer, we do gas nitriding. And then chrome plating. Very few liners we are doing chrome plating at our this thing. And this is one of the important operation, and I can say it is a roll burnishing. We call it as deep rolling process, where we do this deep rolling process under the flange, cylinder liner flange, which will give the strength, which will increases the strength of the flange. So in the high load engines, collar breakage is the normal phenomena for cylinder liners. So to have that collar strength, we have taken this technology from one of our US customer. So we developed this technology along with this collaboration sort of thing. And we are doing many liners with deep, this roll burnishing or deep rolling. And these are the process controls, like in foundry, in machine shop also, we have the tooling controls for buzzer system, and also the base and plateau honing. We have air sizing for automatic size and all. And normally for all the critical characteristics, we could able to achieve the process capability of 1.33 to 1.67. And coming to the challenges, what we have or what we are facing and how we are addressing. Our industry is a high labor intensified industry. Even though we are doing 400 crores, we have the manpower of around 2,000 employees in all the plants put together. So very high level for labor intensity. And also due to the recent RM increases, so we have customers are supported to some extent, and we have done some improvements. So because of that, even the market is very good, but we are getting very thinner margins. That is the challenge. And casting quality, sometimes we are using refractory coating. I think suppliers are here. So sometimes we are getting some inconsistency always. So that is affecting our casting quality. So suddenly some increase in the rejection. So we need to call the supplier and all. So we have developed 2-3 suppliers. Now existing suppliers are also performing very well. So that is one of the challenge. And unorganized brands and small suppliers in Rajkot, even they are making a lot of competition for us, because we have 25% of business in the aftermarket. So always they are very much competitive in Rajkot, all of you know. So it is a very big, it is not a threat, but definitely it is a challenge for us to compete with them. And then, as I told, availability of manpower to work in the foundry. So if you see in Vijayawada, in summer, the temperature will be around 48, 49. So in summer, it will become even 50 also. So getting the manpower during these regular days is okay, but getting the manpower during summer days, it is very difficult for us. It is every year it is a threat, it is a like now firefighting to all my team members in getting the manpower. And government policies sometimes, because we are having furnaces which is almost we are melting around 4,000 tons every month. So our power bill is around 2 crores to 2.5 crores. So there is an increase in the power around 1.5 rupee last April. So the burden to the company is almost 40 lakhs to 50 lakhs per month. So definitely this is a one government policy, and also in April and May there is a one-time activity. Government has restricted us to use only 50% of the power. Power will be available, but we should not use more than 50%. So that is really, it became a challenge for us to feed all our customers where we are already single source status. And China competition in export. So we supply a lot of parts to Cummins, John Deere, and also Volvo. So we are competing with China. Now very recently, now I think we could able to make up with China. Previously it is very, these things. So these are the challenges. And at the same time, as I told you, how we are facing these challenges, how we are addressing these challenges. In our company, we always drive for the productivity. Productivity in terms of foundry, what is that? We call it as production per man per day. In the machine shop also we do. So always we drive for the productivity improvements, and also cost reduction initiatives. As a part of every year business plan preparation itself, our management will give us the business plan objectives. So as a part of business plan objectives, always cost reduction is a driving factor. It will be the part of the business objectives always. So we will deploy that cost reduction projects across all the plants, across all the departments, and we are driving these initiatives to contain the cost. And third one, maintaining the manpower. So you can't believe, for up to last 2 years, we don't have single migrant worker in our factory. We run our factory all with our local manpower and all. But last 2 years, because of the government schemes or because of the nature of work, no local person is willing to join in the foundry. So what we have done is, so we have started taking the migrant people like from Bihar or Orissa, and we are giving the lot of amenities to them. We have put some employee quarters sort of thing. We keep them in the quarters, and we give all the facilities. We give the free lunch for them, and all the amenities, whatever, to retain them. We are taking a lot of initiatives to retain them, because without manpower we cannot run many of the operations. So we have seen the corona during the corona period. Corona period, government allowed only 50% of manpower. So if I am taking only 50% of manpower, I cannot allocate all the people to all the operations, because skill also is an issue. So that's why manpower is very important. So we are taking a lot of activities, this thing. And also we are upgrading our manufacturing facilities to reduce the dependency on the manpower. I will show you some the next one. And for the power, actually our management has taken a decision, and we have ordered for 1 megawatt solar power for our machine shops. Because for foundry it may be difficult, because we require a lot of power. For machining in our Visakhapatnam plant, we started solar power and we ordered, and installation is under process. So power, we want to contain that cost. And we started till now in the capex, always we give only machinery addition. Now we are allocating budget of 1 crore to 1.5 crores every year in the automation. So we want to do automation in this thing. So these are some of the facilities, sir. You can see previously it is all manual line. There will be manual line. We used to have around 12 people per line per shift. Now we are using carousel machines where we have only 6 people, and all the carousel and the dusting environment, everything has been reduced. And now really I can say getting the people, even we are getting the limited people, we made the foundry process from man dependent to I can say machine dependent sort of thing, and it is a semi-automatic machine. So even with anybody, even with these migrant workers, we could able to maintain the foundry production without any quality issues or without any drop in the productivity. So these are the some of these things in foundry. And in machine shop also, as a pilot project, we have introduced the robotic automation. So we have taken one line to robot. So where this robot will be handling 3 machines. You can see 3 CNC machines it will handle. And the component weight also here around 13 kg. So whenever we engage the people for manual 13 kg, we used to have attrition there. They will work for 6 months and they will leave. So now we started in one project and already second project also. This became successful and we are running for the last 1.5 years. Now we ordered for one more robot where we have very high weight of casting. So we introduced the automation. And so as Star told, low-cost automation, it is not only the robot. So a lot of low-cost automations we can do where we are having issues for the manpower. So our journey continues. Thank you.
For a valuable speech about the centrifugal casting processes, your advanced technology and process, and a collaboration with US. You also touched upon the pain point of retention of people and migrant workers. So thank you again. Now I would request Mr. Raj Mohan, Council Member, Chennai Chapter IAF, to facilitate Mr. Gopal Rao with our traditional Angavastra. Now I request Mr. Varadarajan sir, past chairman IAF Chennai chapter, to present him with a memento.
Thank you very much.
Thank you, sir.